Good morning, everyone. Hope all is well. This is a lecture on the first part of 7.6 vectors. We will cover the second part or close out 7.6 on next class. So let's get started. So quantities that involve both a magnitude and direction are called vector quantities, which are vectors for short. All right. Example of that, you are driving due north at 50 miles per hour. The magnitude is the speed, which is 50 miles per hour, and the direction of motion is due north. All right, quantities that involve magnitude but no direction are called scalar quantities, or scalars for short. A scalar has only a numerical value. So an example of that is just the temperature of the room that you are in. All right, a line segment to which a direction has been assigned is called a directed line segment. All right, the directed line segment, P to Q. Here's a diagram of what that would look like. P would be your initial point, Q would be your terminal point, and then your symbolism right here, P to Q with the arrow over P and Q. All right, so the magnitude of the directed line segment, PQ, is its length. So this would be the symbolism that we use. Just like we did absolute value signs or absolute value lines, we have double absolute value lines. That's the magnitude of PQ, or in other words, the distance from P to Q. Vectors do not have negative magnitudes, and vectors are often denoted by bold-faced letters. So I tried to do the best I could right here with a bold-faced V, but when you look at it in the book or in any notation, you can clearly see that your letters that are vectors are bold-faced. So that's vector V, and then vector V goes from P to Q, with P being its initial point, Q being its terminal point. All right, finding the magnitude. If I have the magnitude of u, or I want to find the magnitude of u, I would do the square root of x2 minus x1 squared plus y2 minus y1 squared. Pretty sure you guys have seen that formula before. That's the distance formula. Your initial point is x1, y1, terminal point x2, y2. Give you a chance to copy. Well, I guess you can pause the video if you need to, right? So if I have vector u with the coordinates for the initial point, -3, -3, coordinates of its terminal point, 0, 3, and I've wanted to find the magnitude, your first point, or your initial point is considered x1, y1, terminal point considered x2, y2. So you plug in your values accordingly. X2 is 0 minus x1, which is -3, and that's going to be squared. Y2 is 3 minus your y1, which is -3 squared. So that would be +3 squared plus 6 squared. And that's 9 plus 36 under your radical. And that's square root of 45. We can break that 45 up into 9 times 5. Square root of 9 is 3. Leave the 5 under the radical. So that's 3 square root of 5. All right. All right, multiplying a vector by any positive real number except 1 changes the magnitude of the vector, but not its direction. And multiplying a vector by a negative number reverses the direction of the vector. All right. The I and j unit vectors. Vector I is the unit vector whose direction is along the positive x-axis. So you're just talking about positive x-axis. And then vector j is the unit vector whose direction is along the positive y-axis. So we're talking about here. All right, so a unit vector is a vector with the magnitude of 1. Now we mentioned unit vector up here, I and j unit vectors. A unit vector is a vector with the magnitude of 1. Representing vectors in rectangular coordinates. So vector v from 0, 0 to AB is represented as v equal to AI plus bj. And so don't forget I and j are your unit vectors. So the real numbers a and b are called the scalar components of v. A is the horizontal component of v, b is the vertical component of v. AI plus bj is called the linear combination of the vectors I and j. All right, the magnitude of vector v with AI plus, that's equal to AI plus bj, is given by the square root of a squared plus b squared. Vector v with the initial point x1, y1 and terminal point x2, y2 is equal to the position vector of x squared x2 minus x1I plus y2 minus y1j. And so that goes back to our distance formula. If I were to substitute in x2 minus x1 for A and y2 minus y1 for A right here, for B, excuse me, y2 minus y1 for B, then I will have my distance formula back. All right, so let's try that out. Let V be the vector from initial point P, 3, -1, to terminal point Q, -2, 5. We want to write in terms of I and J. So if our initial point is 3, -1, that's going to be x1, y1. Terminal point is -2, 5. That will be x2, y2. So you plug those in accordingly. x2 is -2. x1 is 3. Then y2 is 5. And y1 is -1. So that should be -5i plus 6j. All right. Adding and subtracting vectors. If we have v being equal to 5i plus 4j and w equal to 6i minus 9j, we want to add them up, v plus w, and all you're doing is combining your like terms. So don't make that anything harder than what it is. 5i plus 4j plus 6i minus 9j. 5i, 6i, it's 11i. 4j, -9j is -5j. And then here we have 5 v minus w. So same thing that you've done in the past with algebra. If you're going to minus a quantity, then make sure you distribute the negative to each term that follows the negative sign in that parentheses. So we have 5i plus 4j minus 6i plus 9j. Combine your like terms, that'll be -1i plus 13j. All right, scalar multiplication. Remember, your scalars are just numbers that have value but no direction. So if I have 6v, that's 6 times 5i plus 4j, and all we'll do is distribute. That's 30i plus 24j. And then here we have 4 times 5i plus 4j minus 2 times 6i minus 9j. Once again, we'll do our distribution. And here we're distributing -2, so be careful. So that's 20i plus 16j minus 12i plus 18j. So 20 minus 12 is 8i And then 16 plus 18 should be 34. J. All right. Your zero vector is the vector whose magnitude is 0, has no direction, and can be expressed as 0i plus 0j. Then the last thing in this, well, not in this section, but the last thing for this lecture, like I said, we will pick up right here on next class to close out the section. But we're just discussing all of your properties of your vectors, your addition and subtraction and scalar multiplication properties. So u plus v is equal to v plus u. And then I should have mentioned before this that u, v, and w are vectors, c and d are scalars. So u plus v plus v plus u plus v is equal to v plus u. U plus v plus w, if you're doing u plus v first and then adding w is the same thing as adding v plus w first and then adding u. So, you know, the first one is commutative property, the second one is dissociative property. Then adding u to 0 is still going to result in u, and adding u to negative u will result in 0. So all of those are vectors. So all those hold true for vectors. After that, we're talking about your scalar multiplication. C and D are scalars, just regular numbers. C times D times U is the same thing as C times D times U. You know, you see the parentheses and switch and what's being associated first. Also, if you have C times U plus V, now U plus V, well, U and V are, you know, your vectors. So you can distribute your multiplication of a scalar to your vectors. Same things if you have C plus D, which are scalars, you can multiply those through distribution with your vector as well. 1u is equal to u, 0u is equal to 0. And then if I have C times V, and I have the magnitude of C times V, I should say, I can pull out C and do the absolute value of C and just do the magnitude of V individually. And multiply by that absolute value of C. Matter of fact, let's do one like that before we close it out. Make sure we see what we're talking about here. So if I have equal to all right, so if u is equal to 2i minus 5j, find the magnitude of negative 2u. All right. So what this is saying, or what that last statement is saying, is that when I look at, let's put red, negative 2, that the magnitude of negative 2u, I can pull the 2 to the outside and look at it this way. Absolute value of negative 2 then find the magnitude of W, I mean not W, but U separately. So that means the absolute value of negative 2 is just 2. And I still can look to find the magnitude of U. Now don't forget, when you go back to the magnitude of U, I'll do it right here. And you have it in your J component. That's going to be square root of A squared plus B squared. So that's 2 times the square root of 2 squared up plus, let me see if I can squeeze that negative in there, negative 5 squared. So that's 2 times square root of 4 plus 25. So it'll be 2 times the square root of 29. And that would be that for you. So let me know if you have any questions. Like I said, on next class, we'll pick up right here, using everything we've done up to this point as our foundation and moving forward to close out 7.6. All right, have a good one.